Hi, this is Ms. Pellegrin, and today we're going to be looking at Module 2, Lesson number 6, the distance between two rational numbers. So today we're going to be looking at the distance formula and absolute value. And so our distance formula is the absolute value of P minus Q. And so then we're going to be looking at subtraction in terms of addition. So because our formula has the subtraction sign in it. Yesterday we were talking in lesson 5 that we do addition of the additive inverse instead of subtraction. And so that's what we're talking about here. And then students solve word problems. So we're going to be looking at word problems dealing with changes in the distance or temperature. Okay, so your classwork, you have an exercise where we have person A and person B. So pink and green, you'll be person A. And so that means yellow and orange, you will be person B. So it says that students may find it easier to see the distance if they use a highlighter, so you're welcome to use a highlighter for this. So we're going to pause the video. Person A, you will work independently, and then person B will also be working independently. Once you've done all three, then you will share your answers together and compare them. Okay, so what was the distance between -4 and -5? And so what you should have gotten, that was the distance was 9. Okay, so the distance was 9. They said a highlighter might be easier, so we're starting at -4. And we're going to 5. Don't go past that. Oops. Okay, for me, I want to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then what was the distance between 5 and 4? And so we were starting with 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so you also got 9. So were you and your partner's answers the same for the second and third problems as well? And so they should have been. We had -5, 1, 2, whoops, -5 and 3. -3, sorry, not +3. So 1, 2, and then -3 and -5. So why do you suppose that we are having these same answers? So we're having the same answers because those endpoints are the same. So there we have, here we're at -1 and +7. Here we were at -1 and +7. The order didn't matter. Okay. So 9, 2, and 8 on both sides. So we've answered those 4 questions. In life, at any given moment, we will always be able to use a number line to find the distance between two rational numbers? No, we could always draw it out technically, but that's difficult. Is it the most efficient way to calculate the distance between 2 points? Okay, efficient. Think about that. Is it always efficient to draw a number line every time you need to know distance or change? No. So what represents the distance between a number and 0 on the number line? Pause the video and think about that. So yes, absolute value. And we're just discussing, but we can definitely jot down notes. If the distance between 5 and 0 can be calculated using the absolute value, notice the straight lines showing that that's absolute value. Calculating the absolute value of 5 minus 0, or the absolute value of 5, do you think we might be able to calculate the distance between -4 and 5 using absolute value? So we're going to take a minute and see if it works. So the absolute value, -4, we said 5 minus 0. So we have -4, and we're going to do minus 5. Okay, and when we said we had subtraction, we said it's the same as the additive inverse. So if we rewrite this, it's the same as -4 plus a -5, the absolute value. And so what is the absolute value of -4 plus a -5? So signs are the same, so you're adding. So we have the absolute value of 4 plus 5, which is -9. Keep that sign. And the absolute value of -9 is 9. So did it work? Yes, because that was our very first one that we had up here. It was -4 and 5. And so it asked us to see if it would work for the other one. So you can be doing that right here. Okay, so let's see if it works for the other one. So we did partner A first, so let's do from partner B, -3 and 5. So, and I just was going down. So -3 minus -5, the absolute value. It's these lines. So then we're rewriting our problem. -3. Instead of addition, we're doing subtraction, we're doing addition. Instead of, forgot the parentheses on this side. So instead of the additive inverse, so subtraction is the same thing as adding the inverse, so adding 5. Okay, so we have -3 and +5, so signs are different. So we are subtracting, and we're going to have a positive answer because it has a greater absolute value. So when we subtract, we get the absolute value of 2, which is 2. So it did work again, and it would work for the last one. Okay. Exercise 2, use the number line to answer each of the following questions. So we want to know, what is the distance between 0 and -8? So you are welcome to use your number line. You also need to be using what we were just looking at, which was the absolute value of P minus Q. But you can use either one first, but use your number line to verify your answer. So you're going to go ahead and pause the video, take a couple minutes. You're going to work independently, so you're working on your own. You're going to take 3 minutes to do each of these problems. Okay, so we have gone and done these problems. So what is the distance between 0 and -8? 1, 2, 3, 4, 5. Whoops. That was silly. And -8. We needed to be going the other way. 1, 2, 3, 4, 5, 6, 7, 8. So I'm counting the distance between both of these. That's why I'm doing the bumps again. Okay, so 0 as P minus 8 as Q. So minus, we already have the minus sign. We have -8. So we are doing -8. Whoops. I'm making all kinds of mistakes today. Okay, so then instead of subtraction, we need to rewrite it. the absolute value of 0. The subtraction is the same as adding the opposite. So the opposite of negative 8 is positive 8. And so the absolute value of 8 is 8. And that was 8 units. Next one, from negative 2 to negative 1.5. So from negative 2 to negative 1.5, we would have gotten that the absolute value, is half. As you are only going the distance of half. So you could write that out. Negative 2, you're subtracting is what we have to do. Subtracting a negative 1.5. Keep forgetting to put the in parentheses there. And then let's rewrite it. We're just getting more practice rewriting subtraction problems here too. So we have negative 2. Instead of a subtraction sign, we're writing an addition sign. Instead of a negative, we're going to write a positive. So I don't even need that parentheses anymore. 1 and 1/2. So negative 2 plus 1 and 1/2 equals, so I'm subtracting and my answer is going to be negative because this has a greater absolute value. And 2 minus 1.5, so I have 2, I'm subtracting, and I have half left. And we can see that on our number line too. Okay, and then what is the distance between negative 6 and 10? 1, 2, 3, 4. Prove it. Negative 6 minus a negative 10 equals, so rewrite negative 6 plus a positive 10, so I'm just going to write 10, equals, signs are different, so we're subtracting. So 10 minus 6 gives me 4. And keep the sign of the greater absolute value, so it is a positive 4. There we go. Okay, in example 1, the formula distance between two rational numbers. Start at negative 3, find the distance between negative 3 here and positive 2. Start on and end point. So that is step 1. Count the number of units from the end point you start on to the other endpoint. 1, 2, 3, 4, 5. If we started at 2, 1, 2, 3, 4, 5. It does not matter the direction. Okay? So, using a formula, we said our formula is P minus Q. So if we went with the negative 3 first, negative 3 minus 2. Rewrite negative 3 plus a negative 2. Same signs, add, keep sign. Negative 3 plus 2 is 5. The absolute value of negative 5 is equal to 5. And what if we went the other way? So we started with the 2. So we have 2 minus, our formula has a minus sign, and then negative 3 equals 2 minus negative 3, rewrite it. 2, subtraction is the same thing as addition, adding the additive inverse. So the additive inverse of negative 3 is positive 3. So 2 plus 3 is equal to the absolute value of 5, which is equal to 5. So it doesn't matter which way you go. That's what we were showing in that example. And we know we can count it that way as well, but it works for your formula too. Okay, so when we're looking at example 2, and notice they had that down there for two rational numbers, P and Q. The distance between P and Q is the absolute value of P minus Q. So in example 2, we are looking at change in elevation versus the distance. Distance is positive. Change in elevation or temperature may be positive or negative, depending on if it's increasing or decreasing, going up or down. So on A, it says that a hiker starts hiking at the beginning of the trail, and the beginning of the trail is 200 feet below sea level. He hikes to a location on the trail that is 580 feet above sea level and stops for lunch. The first part says, what is the vertical distance between 200 feet below sea level and 500 feet above sea level? Okay, so in this part, we're only going to be using the formula. So he's starting at 200 feet below sea level. So this is a negative 200. He hikes to a location that is 500 feet above sea level. So this is positive 580. Okay, so the absolute value, doesn't matter which one we start with. Negative 200 came first, so I'll put it first. Negative 200 minus, and then 580. Rewrite. Negative 200. The opposite subtraction is the same thing as adding the additive inverse. So the additive inverse would be a negative 580. Equals the absolute value of those two. So we have the same sign. So we're going to be adding. So we're going to add 580 and 200, which gives me 780, the absolute value of 780, which is 780. What is the vertical distance between 200 feet below and 580 feet above? The vertical distance is 780 feet. How should we interpret 780 feet in the context of the problem? So we're talking about the hiker. So the hiker, this is getting me context of the problem. Hiker hiked 780 feet from a point below sea level to a point above sea level. Okay. Part B, after lunch, the hiker hiked back down the trail from the point of elevation, which is 580 feet above sea level, to the beginning of the trail, which is 200 feet below sea level. So now we're being given a number line, a vertical number line, so that we can actually see what we're showing here. Obviously, we are not going to do 580 little tick marks all the way up. So I'm just going to say this is going to represent 580. Okay, and then negative 200 is obviously going to be below it. Okay, below sea level. So here would be my sea level. and it's not going to be as far as 580. So let's just put it right here. This is representing negative 200, and this is representing the sea level. Okay. So we're looking at after lunch. Before lunch, he went from here, so this is what we did in part A, up to here. And we said that that was 780 feet. After lunch, he is going from the 580 feet back down to the beginning of the trail. That is 200 feet below sea level. So this is beginning of trail. And this is, we said this is before lunch. And this is after lunch. Okay. What is the vertical distance between 580 feet above sea level and 200 feet below sea level? So like I said before, the order doesn't matter. Good thing I did start off with what I was given first on the last one. So now we're doing 580 feet minus, and then 200 feet below sea level. So that's negative 200 equals the absolute value. Let's rewrite it. 580. Change it to addition. Change negative 200 to positive. It's additive inverse. So plus 200. And we already know that adding those two things together gives me 780. So what is the change in elevation? The change in elevation is 780 feet. Okay, in exercise 3, you are going to work with a partner. You're going to take 3 minutes. And it says the distance between negative and a positive number is 12.5. So our distance has to be 12.5. What are the numbers? Yours does not have a number line, but you're welcome to go ahead and draw one just like I have here. So go ahead, work with your partner and see what you can come up with. Okay, so your answers will probably vary on this one and be different. So let's look at a couple of things. What if we had one endpoint at negative 9? We know it had to be 12.5 as the distance. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. So then the other point, so you would have had negative 9 as one point. Whoops. And then your other point would have been 3.5. So those could have been your two numbers. What if we started somewhere else on our number line? What if we started at 8? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. Okay, so then we had 8 and negative, remember, let's look, 3, negative 3, negative 3.5, negative 4, negative 4.5. So negative 4.5. Okay. Could you have started at a halfway point? Sure. What if we start at negative 2.5? Negative 2.5. 1. We're going to halfway points. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a half. Okay, so we had negative 2.5, and then we have 10. It ended at 10. Exercise 4, use the distance formula to find each answer. Support your answer using a number line. Okay, so we have the absolute value of negative 7 minus negative 4. So the absolute value of negative 7 plus 4 equals, we're subtracting absolute value of negative, so that has a greater absolute value. Gives me 3. The absolute value of negative 3 is 3. Support your answer. You are at negative 7, 6, 5, 4, 3, 1, 2, 3. Find the change in temperature from negative 18 degrees to 15 degrees. So from negative 18, so we're starting at negative 18. So what might help you to think about this is if we're starting at negative 18, we have to go from negative 18 up to 0. So that's 18 spaces. And then from 0, we have to go up 15 more. So we're going up 15 more. So then this is 15. So then together, 18 plus 15, 8, 9, 10, 11, gives me 33. Okay. And then it said to use the distance formula, so let's show it that way too. Negative 18 minus 15. So then the absolute value of negative 18 plus a negative 15 equals, they're the same sign, so you're adding them. So we're getting a negative 33, and the absolute value of negative 33 is 33. Change in temperature is 33 degrees Fahrenheit. Would your answer for part B be different? And explain? No, the end points are the same. So let's look at our lesson summary. To find the distance between two rational numbers, you can count the number of units, or you can use the formula P minus Q. Distance is always going to be positive. Change may be positive or negative. For instance, there is a negative 4 degrees change when the temperature goes from 7 to 3 degrees. Okay, but with that, so we wouldn't say it dropped negative 4 degrees, because then you're saying this is negative and this is negative. So you have to choose which one you're saying. Either it dropped 4 degrees or it has a negative 4 degree change.